Alright, Crouton Ramon's houseofmath.com. It has come to my attention that a lot of the reason why you guys are having a difficult time with unit circles is because a lot of people don't understand that these points right here are the points on the triangle when you circumscribe the triangle inside the unit circle. So what you see here is you see all of these points and all of this, but you don't see the triangles. They're leaving out the fact that this line and this line form a triangle, and what you're talking about here is this distance is your cosine and this distance is your sine, because we've made it a unit circle. What we've done here is we've taken this triangle and put it on the unit circle. So this now, instead of this special triangle being 1, 2, square root 3, you divided each side by 2 so that it'll fit on the unit circle, obviously, to make the hypotenuse a length of 1. So this is divided by 2 and this is divided by 2. Which now makes it so that my x is the same as my cosine and my y is the same as my sine, because we're just, what's the definition of sine? You need to know what the words mean. Sine is opposite over hypotenuse. Well, the hypotenuse is 1 now, so it doesn't matter. Whatever this is just 1. And then same thing, we take, is just over 1, I mean. So it's a half over 1 is a half. Square root of 3 over 2 over 1 is just square root of 3 over 2. And then we take this one, the third one, the 45-degree angle triangle, special triangle, and this is going to be square root of 2 if it's a regular triangle. Let's clean this up a little bit over here. And we can see that this is supposed to be a triangle that is that 45, 45. Well, this would be square root of 2 if this was 1, 1, 1 square root of 2, but we can't have this be square root of 2. It's 1. So this 1 right here means that I took everything and divided by square root of 2. Well, if I divide by square root of 2, in other words, if I take and find my opposite over hypotenuse is 1 over square root of 2, well, then I have to take square root of 2 and rationalize it, because I don't like 1 over square root of 2. I have to multiply by square root of 2 over square root of 2, and I'll get square root of 2 over 2. Which is why at pi over 4, the coordinates are square root of 2 over 2 by square root of 2 over square root of 2. Or excuse me, over square root of 2 over 2. Because that's this point. This distance here is the square root of 2 over 2, and this distance here is the square root of 2 over 2. So that point right there is defined as square root of 2 over square over 2. Right? Square root of 2 over 2, square root of 2 over 2. All these are points of the triangle. So all we're doing is organizing our thought. And then once we get there, it becomes very easy to understand what we're doing. But if I have stuff like this, let's see here, let's go over here to this web page that tries to explain it. They show you that, yes, I put the triangles on there, but look, then they put the tangent outside, and yes, you can, but the definition of tangent is just opposite over adjacent. And, oh, look here, well, before I get there, let's do this. Here is, this is very nice. I like it a lot, actually. But look, it shows you sine 60. There is 0.866 and 0.5. Well, yes, that's 0.866 is the same thing as square root of 3 divided by 2. What they don't see, or what most children don't understand, is that here at 30 degrees, let's get to 30, well, of course, that's 0.5. The green is 0.5. That's just that triangle. And this over here is, right, that's just this over here and this over here. That's square root of 3 divided by 2 is 0.866. And here at 60 degrees, we can see that it switches. Now it's 866 is the opposite, and the adjacent is 0.5. And the hypotenuse is still just 1. But this all gets lost on the children, and they don't understand, or the students, they don't understand that what we're talking about is just the distance. So of course that point right there is x and y, and this, if it's 30, 60, 90, and this is 60 degrees, then this is going to be a half, and this is going to be square root of 3 over 2. And then of course we can see that if I take x, Pythagorean theorem says a squared plus b squared equals c squared. Well, when it's applied to the unit circle, it's just x squared plus y squared equals 1 squared, or cosine squared plus sine squared is 1. squared. That is the basic identity, trig identity, and that's why you'll see here I have them drawn out. Oh, can you see them? You can't see them. There you go. You can see them drawn out over here. That look, sine squared. Right? So you get the basic identities here, and they're easy to understand. And the kids, it's not difficult for them to understand what's going on there, and it's fun. And you know, learning can be enjoyable if it's done right. Then we can put this on a table, of course, just to put out the information here. But now look what they did the tangent here. They made the tangent rather confusing. It's true that it's sine over cosine, but couldn't it just be opposite over adjacent? Let's look at this over here, because that's the definition. At 30 degrees, it's opposite over adjacent. 1 over the square root of 3. I don't have to do all this extra fun math over here. I can just look at my triangle and see that it's 1 over the square root of 3. Of course, it's sine 30 over cosine 30, which is 1/2 over square root of 3 over 2. And when you divide those things, you are going to wind up canceling out the 2's, find the 1's, and you wind up with 1 over the square root of 3. And then the last thing we have to do is, they don't show it to you, but we're going to multiply by 1, square root of 3 over square root of 3. And when we multiply by 1, we don't change anything, do we? And we get square root of 3 over 3. Okay. And then they have some quick sketches here that are good, actually, and I do go over these. But again, when they show you the unit circle, they don't show you the triangles. That's the problem. You need to understand that they're just triangles inscribed in the circle, and we can organize our thought by putting them that way on our unit circle. And then understand that now, of course, this becomes the same thing as sine, and this becomes the same, this becomes the same thing as sine, and this becomes the same thing as cosine, because my x component is non-different than my cosine, and my y component is non-different than my sine. And that all we're doing here, because I've made this 1, is making it actually easier, not more difficult. Okay. This is going to be on this page right here. And like I said, I showed you a quick video on how to take a pineapple and teach math with it. We cut it into a hexagon here. So this is a 6-sided figure. And then we're going to show you how to take it and cut that 6-sided figure up so that you can get some triangles, and then turn those triangles into rectangles. And that's what we're basically doing, using mathematics to keep track, using our symbols to keep track of all these triangles and summations and so on. So anyway, here's a quick picture, and you get some more video, and you get to this page. That page looks like this. It has videos on yet more videos. You're just teaching, following along. This is a bonus video, but this shows you how to derive pi r squared. They're super short. This video is like 6 minutes long. I don't know how long this video is. That's another 4-minute video. So I mean, in 10 minutes, you'll have more understanding of the derivation of pi r squared than most students do their whole entire high school careers. All right, CrewThunderMonesHouseOfMath.com for more.